Hi guys, these are your notes for section 7.4, and today we're going to talk about compound interest. I think that a lot of you will find this section interesting, and some of you probably have seen aspects of this before in any business class you may have taken or an accounting class. I don't know if you can take accounting yet, but those of you who are going to be interested in accounting anyway, this will be a pretty motivating section for you. All right, let's talk about money for a second. There's some vocab you need to know with money, and I think most of you probably already know these words, but in case you don't, principal is the original amount that you invest. It's also thought of as the present amount. Sometimes if you are going to plug in something that has already accrued interest and you're going to start over, it's that original amount that you're going to invest, okay? Annual compound interest is when interest is earned once at the end of each year. We call it annual. And it's compounded means how much time they add the interest to it. Okay. Semi-annually means that it's going to happen twice a year. Okay. Quarterly makes sense, 4 times a year. And daily usually uses 360 or 365 days. We will tell you which one to use. Okay. And annual percentage yield is talking about how much money is kind of made on $1. So it's the rate of interest earned after all compoundings have taken place, and it can tell us how much basically $1 will make in 1 year, no matter how many times it's been compounded. Okay, I will be 100% honest. This is not my cup of tea. I don't really like finance stuff that much. If you want somebody who's super excited about it, then we're going to talk to Mrs. Wiffle, because she really loves money. And I like money. I just don't like to do math with it as much. So I'll do my best. Bear with me if I make any mistakes, but hopefully I won't. Okay. Formula you need to know. This needs to actually, I don't memorize. Oh, this is the one I do memorize. There's one in the book that looks like this. A equals P times 1 plus R over T. And this is the annual compound interest formula. There's no need to memorize this one because this one covers it. This is the general compound interest formula, and this one covers both. You need to know what all of these variables mean. A is basically your total amount. P is the principal. That is the amount invested, the original amount. 1 comes from when you're making money from interest. You can't, if I say like the interest was 2%, I would be multiplying by 0.02. That will make this principal smaller. After that, I would have to add to it my principal again to see how much total money I made. That's why if we're trying to figure out how much money we made, we're going to add 1 to it, because that's 1.02 or 102%. And that's how you figure out how much money you make, because you have to add into it your original amount in addition to the percentage that you're earning. So that's why we put the 1 there. So 1 is giving you the 100%. Plus R is the interest rate, and we're going to write that rate as a decimal. N is the number of times compounded. So if it's quarterly, we plug in 4. If it's daily, we plug in whatever it told you. If it's monthly, you plug in 12, so on. And once again, is the number of times compounded is T, is time in years, okay? So this is why this is the annual compound interest formula, which you may have seen before in your Algebra 1 books, and this is the general. This number of times, if it's annual, would be 1. So you'd plug that in over 1, and then it's 1 times T. So it's covered in the general compound interest formula, okay? So this is the one you need to memorize, and it will show up again and again. It will show up on your tests. It probably will show up on tests later down the road since they're cumulative, and definitely your final. Okay, to find APY, when they ask you to find APY, you're going to find the interest that $1 makes, okay? After you find the interest that $1 makes, you will change that to a percent. Okay, so let's do some APY questions, okay? Find the annual percentage yield on the account with a given description. 6% interest compounded quarterly. So the formula is A equals P times 1 plus R over N to the NT. We want to know how much a dollar will make. So A equals 1 times, and again, eventually you won't need to write this 1 in. 1 plus, the rate is 6, so 0.06 over number of times compounded. Quarterly tells me that N is going to equal 4. Number of times compounded 4. Time, annual, that's the key word there. Time is going to be 1. Okay, that is going to be 1 plus 0.06 divided by 4. Definitely need your calculators today. 1 plus 0.015 to the 4th power. 1.015 to the 4th power. Okay, I got 1.06136 ... Okay, so the annual percentage yield is how much percent, what did we say here? The interest that a dollar makes. Okay, so how much interest am I making? Well, I take off the dollar and I change this to a percent. So I'm not really making 6% because that is being compounded quarterly. Overall, in 1 year, I'm actually making 6.136%. So what happens is when things are compounded more, you're going to make more money. This should make sense because you're making money on that earned money. So a percentage of something greater is going to give you more money. It could amount to pennies on the dollar, but it does amount to something, especially when you're dealing with large quantities of money. So usually, the more times compounded, the better. Now, a lot of times they try to make some sort of fee or something for a higher rate or for more compounding because it will take the bank time or energy, not really because the computers do it, but to figure out what your current account balance is when you earn interest. But that's why this APY is the best thing to look at to see how much money you're actually going to make. Okay, 8% interest compounded semi-annually. Okay, let's talk about this. Your R is going to be 0.08. Number of times compounded semi-annually is 2. Time is still going to be 1. P, again, it's just for $1. So let me go with this right here. Okie dokie. A equals 1 times 1 plus the rate is 0.08 over 2 to the 2 times 1. We now have 1 times 1.04 squared. I have 1.0816. Cross off the dollar, change this to a percentage. I'm actually going to be making 8.16%. Okay, I hope this APY makes sense. Be prepared to see that again. Okay, this is funny. I like the name U because you can make all sorts of jokes like, you did this. Okay, you invest $500 in a savings account. Okay, it pays 3.2% interest, compounded annually. How much money will be in its account after 5 years if no deposits or withdrawals take place during the 5 years? Okay, here's our formula. A equals P times 1 plus R over N to the NT. Okay, what was the principal? Well, he started with $500. 1 plus the rate, 0.032. Number of times compounded is just once. Take the 1 times 5 because that will be the total number of times it's compounded. 1 time, but 5 years, so a total of 5 times that we're going to compound that. 500 times 1.032 to the 5th power. 1.032 to the 5th power. I'm going to do that first. Enter. Take it times the 500. And you makes, I should say, $585 and 20, looks like 9 cents. I don't know if banks round up. It's a good question. One of you probably knows. I'm going to assume they do. Okay, next one. Debbie invests $5,000 in a 5-year CD that pays 7.8% interest compounded quarterly. I've been told that Mrs. Wolfel hates CDs. You guys can tell me about it later. The CD matures next February. If no deposits or withdrawals have taken place during the 5 year, how much money is it going to be? Okay, let's do this. There's my formula. It's so cute. All right. What I got here? I got the principal is 5,000. The rate looks like 0.078. Number of times compounded. That's the one you always have to look for. N equals 4. Total number of years is 5. Okie dokie. I got 5,000 times 1 plus 0.078 all over 4 to the 4 times 5. I'm just going to go ahead and put 20 there. 0.078 divided by 4 plus, so we got 1 point, oops, easy, 5,000 times 1.0195 to the 20th power. Go ahead and do this part first. To the 20th power times 5,000. Whoa, I like this one. I got $7,357.23. I think that's good because I'm like, oh, look, she started with 5,000, but now she has this much. She didn't touch it for 5 years, so it's something to keep in mind. And this is a good rate. And it's compounded quarterly. I don't think there's really CDs out there that look like that, but maybe I'm wrong. I don't know. But yeah, that's a pretty good turnaround, I think, for doing nothing to it except not touch it for 5 years. So, I don't know. Maybe they're really wimpy now. I think most of them are below like 2% probably. This is super good problem. And this is stuff you guys will have to deal with in your future, okay? Bank X pays this interest on a savings account. It's compounded monthly. Bank Y pays this interest compounded daily. Okay, well, which one should you use? This is a duh. I wish these two numbers were like slightly different. That would have been a better question. But which bank should you use? Let's say this. Bank Y is what we should use. How come? Because it's compounded more. Okay, the more times it's compounded, the more money you're going to make. Like I said, I wish that this was like 2.7 so that you guys could see how close it gets. But let's talk about the money difference. This might be interesting to you. You have this much money to save for 3 years. How much more money will I have at the end of 3 years with the bank you choose? So this is 2 problems for the price of 1. I know you guys like a good deal. Rate is 0.0275. N here is 12. Time is how long? 3 years. Principal is 3,500. So A equals P times 1 plus R over N to the NT. Okay. 3,500. 1 plus 0.0275. Number of times compounded on the first one is 12 to the 12 times 3, which is 36. 0.0275 divided by 12 plus 1 to the 36th power first. Store that in your calculator times the 3,500. Make sure you are typing these in properly. And at this first bank, it looks like I get $3,800, 64 cents. That's being rounded. Okay, let's try the next bank. In the other bank, the rate's the same, but now my N is different, 365. So 3,500, 1 plus 0.0275 divide by 365. 365 times 3 is 1,095. Let's type this into my calculator. 0.0275 divided by 365, I get a decimal, a little baby 1, plus a 1 to the 1,095 power times 3,500. I get $3,800.98. Wow. Definitely go with Bank Y. You can buy a gumball. Okay. So what is it? What is the benefit? Here in your case, not much. What if I was investing billions of dollars? Sure. It will make a difference. When your amount is not that big to begin with, it's not as big of a deal. But if these rate numbers were a little different, you would have seen some differences, I think. Okay? Alright, let's try this. Suppose $2,500 invested for 1.5 years. Ooh, that's fun. So T here is going to be 1.5. That's fun. Plan A plays this, or a little bit different, compounded daily. B is this, compounded quarterly. If the investment is untouched for the entire time, which plan will earn more interest? How much interest will each plan earn? Okay, this one is a little bit better because the numbers are a little different, so it's not as obvious. So let's go ahead and plug them in. A equals principal 2,500. I'm looking off my formula up here. 1 plus the rate is 0.0312. Daily first, and it says 365 to the 365 times 1.5, 547.5. Okay, so 0.0312 divided by 365 plus 1 to the 547.5 power times 2,500. $2,619.78. That is rounded up. Next bank, Plan B, 2,500 still. 1 plus 0.0313. Quarterly is divided by 4 for 1.5 years. That is to the 6th power. 0.0313 divided by 4 plus the 1 to the 6th power times 2,500. $2,619 and wait for it, 70 cents. How much interest will each plan earn? Okay, well, which plan earns more interest? It looks like Plan A is better. And they want to know how much interest will each plan earn. You take this, your new, subtract the original, 2,619.78 minus 2,500. $119 here, 78 cents. And 2,619.70 minus the 2,500, 119.70. Okay. Fun time with investments. That's all for today. I think it's enough practice problems. The biggest deal is just memorizing that formula, and that's not going to be that big of a deal for you guys. All right. See ya.